So today we'll try to model a car bumper, impact test of a car bumper. So to model it, we have imported this file, CAD file. These are CAD file. These are basically shell elements. So we'll take it to the assembly because in part we have two different parts, right side and left side. So in assembly, we'll join both of this. We'll click OK. Now what I'll do is I need to merge it. So I'll use this option for merge command. I'll name it as bump bumper merge. I'll simply merge it. I'll retain this face, partition, so I'll keep it this. I want to retain this line, or I would say this partition. It will be merged, but this partition will be there. And if I don't want to retain, then I'll simply keep it like this. So let's do one thing, because usually it does have some partition here. So I'll simply retain it, continue. I'll select both the instances to merge. So this is the merged part that we have now, and it is available in assembly also. So this is my recent part that I have created after merging. I'll delete these two because I don't need this. Now I'll simply go to mesh. I'll go to part. I meshed it in part because this is independent, this is dependent. If I make it independent, I can mesh it in assembly, but I'll keep it independent. It does not matter wherever you are meshing it. So I'll keep it, let's say 2.3 mesh size, and mesh it. So this is my mesh. So this looks quite bigger mesh, and I have only 544 elements. So what I would say, I'll reduce the mesh size little bit more. Okay, let's say it's 2700 elements, so it's quite okay, but this mesh looks quite fine. You can reduce the mesh size further, but I'll not do that. Now next I want a impactor which will be impacting this car bumper. So for that I'll create a rigid body. A rigid body means there will be no deformation on the body. I'll assign some mass into it, and it will be acting just for the impact part only. So I'll keep the diameter as 10 mm. So I'll assign the radius as 5 mm, and I'll extrude it up to, let's say I'll extrude it 20 mm. Okay, I'll extrude it little bit further also. Let us extrude more. Let's make it 40. Okay, now it's quite okay. Okay, let's increase little bit more. Make it 100. Now that's okay. We'll take it to assembly. Okay, so the error says that I cannot take it as solid, so I need to convert it using shape shell from solid. Because I have created it as solid, so I need to convert it to shell. From solid, done. Now I can take, but before that I'll create some partition. For that I'll simply will have x plane, xy plane, yz plane, and xz plane. This will help me to get some points, and it will be easier for me to place the object wherever I want. So I'll use this face partitioning. I'll partition using datum plane. I'll select whole face. I'll select this datum plane, create. Again I'll select whole face, done. This datum plane, create. That's all. I'll take it to the assembly now, and I'll rotate it now. So first one will be 0, and I'm basically defining here the axis. So first point is 0, next point is 5, 0, 0. So my rotation axis is x-axis, and it will be 90 degree, or I would say minus 90 degree. So here, now what I'll do is I'll simply hide the rigid body first, and I'll create a point at some distance from here at some distance on the z side. So on the z side, let's say keep it 10 mm apart. X0, Y0, Z will be 10 mm. So I have a point. Now I'll place my rigid body on that point. So I'll translate my rigid body using this point to here. So over here, as you can see, this much gap is there, so I can reduce the gap more, because the more the gap, more will be the time required for the solution. So I just want to reduce that time, so I'll again create a midpoint between these 2 points. This I'm just placing the impactor. I'll move from this point to this point. So let's check. Oh, this is okay, quite okay. I can reduce more, but no problem. I have already created a model. I just want to check the diameter. I think I need to reduce the diameter, because in this model I have used the diameter is 10 mm. Okay, here I have used length around 200, but here in this model I'm using less as 100, so it does not matter. It depends on you, what is the diameter you are using or what is the length you are using. So let's check the diameter of this model. It is 10. Okay, that's fine. Now I need to assign some mass, so I'll simply go here, inertia. First let me check the mass. What is the mass I have assigned previously? You can assign mass from here also, and in the part also. Both the options are available. Here I have assigned as a part, so it is in ton, because I am working in mm. So whenever you are working in mm, then always you should input the mass value in ton. That's how ABAQUS works. So this is my rigid body. I'll simply assign mass from here. Before that, I need to assign a reference point. So I'll simply go to tools, reference point. As it is a rigid body, I'll assign a reference point, and I'll assign a mass here in the reference point. Paste it. This mass is in unit, is in ton. Done. Now I need to assign some property. I don't have to assign any property for the rigid body, because it is rigid and it does not require any property. But for the this bumper, we need to assign some property. So if you want to create property material, just simply go here in density, enter the value, and then we have elastic. Here enter the value as per your requirement. So as I have already created the material model in model 1, so I'll simply copy it, and I'll show you. From model 1 to I want to copy the material to model 2, and let me show you the material that I have created. And the density will be, this unit is in ton per mm cube, and this is Newton per mm square, and this is the Poisson's ratio. An expansion value was given, so I have just simply given expansion value. So you can go to mechanical and expansion, though it is not required because it will be used in thermal analysis. We are not doing thermal analysis, so it is not required. Now I'll simply assign the property. Go here, select the part where you assign the property. You want to assign the select shell homogeneous. You can give suitable name here. I'm not giving here. And here the thickness is 2.75. so this is in mm. So this is the thickness I have assigned to my this what is called bumper. Next I need to mesh the rigid part, because I have meshed this one, the bumper. Now rigid part you can assign any mesh size. Let's say assign 3, any mesh size as for your convenience. Now this mesh size, how it is defined, it is to be defined using mesh conversion study. In mesh conversion study, what happens, suppose you have given particular mesh size. Let's say we have given 3. Now for 3, whatever result you got, let's say stress for 3 mesh size you have got 5 MPa, and for stress for 5 mesh size you got, let's say 10 MPa. And likewise for 5 mesh size you get 10 MPa, for 3 mesh size you get 5 MPa, and likewise you keep on decreasing, like for 2 mesh size you get 4.5, and for 1 mesh size you get around 4.4. so you see, initially for 5 mesh size it was 10, for 3 mesh size the stress value was 5, for 2 mesh size the stress value was 4.5, and for 1 mesh size it is 4.4. so what happens, as you can see, if I keep the mesh size around 1 or 2, my result is not changing much, so that will be my ideal mesh size. That is how it is defined. But for the time being I am not doing any mesh conversion study, so I've randomly taken some mesh size. That's all. Next we'll go to interactions. In interaction I need to define, before interaction I will define a step. It will be a dynamic explicit, and dynamic explicit, as I am moving it at 20 km/h, so if I convert 20 km/h in mm/s, so it will be around, I have already calculated the value and I have entered in my previous model. It will be around 5.55 meter per second. So in mm/s it will be 555, because 5.55 meter per second will be equal to 20 km/h. So in mm/s it will be multiplied by 1000. So this will be your speed. Now as we can see, we have kept the impactor at a distance of around let's check what is the distance between these two. Let's check the distance. Okay, this is for model 1, this is my model 2. I need to check the distance here. I have kept it around 5 mm apart. So as you can see, if my impactor is moving at this much mm/s, so to reach 5 mm it will barely take 0.001 second, isn't it? 0.004 second will be sufficient. If I multiply 0.001, then it will be 5.55. so what I will do, I will simulate it for 4 seconds. 0.004 second. So for that I'll go to step, and remember this is model 1, so if you just create it for, then it will not work. I'll have to change it to model 2, because this is the model on which we are working now. So I'll create a dynamic explicit step, and it will be a time period of let's say 0.003 second. It will be sufficient for simulation. Okay, now I'll simply go to interaction. I'll create a general contact explicit. I'll make it initial. Done. Here the interaction property I'll have to create is tangential behavior penalty. Let's say give a penalty of friction coefficient 0.5. And normal behavior means so let's suppose you want to push your hand against the wall, so you cannot penetrate the wall with your hand. So that's how the normal behavior works. So it will tell the software how to behave, and friction basically the tangential behavior. So name itself suggests, and if you want more detail you can simply google it, tangential behavior, normal behavior, abacus. It will give you uh, the exact details. And interaction, you can use surface to surface interaction. That means this surface to this surface, how it will interact. But I am using general contact, means I have only these two elements over here, only two objects over here, and all the objects will use the same interaction. That's why I am using that. So let's create the boundary condition. So for boundary condition, what I'll do first is I can simply fix I'll simply fix all the edges of the bumper. So before that, what I'll do, I'll simply hide the rigid body. Sorry, this is for model 2, and I'm working in model 2. So I'll simply hide the rigid body, and here I'll create a coupling so that I can simply assign the boundary condition at a particular point. So I'll first, okay, no, not this point. I'll create a midpoint in between these 2 points. I'll assign a reference point, and what I'll do, I'll tie all the outer edge with this reference point. Done. Then it will be node region, and node region will be all the outer edge. So for that, what I'll do, I'll simply select like this, and I'll unselect all this, press control, and you can unselect all this. Like this, like this. Just check. Yeah, all the edges are all only boundary edges are selected. Just do like this. I don't want these faces also. So now if you just rotate it and see, okay, there is something. This one I need to unselect. Okay, so done. So see, all these edges will be tight. Basically I have used coupling. So what I'll do, when I have to assign the boundary condition, I'll just simply select this reference point, and it will be sufficient, and it will apply boundary condition to all the side edges. I don't have to select individual. That's all. Now I'll unhide the rigid, and I'll apply boundary condition to this reference point, because this is a rigid body, and whatever way this reference point will behave, all the rigid body will behave similar to that. So this is an initial step. I'll fix everything. I'll go to boundary condition manager. So BC2 is my this for rigid body, but you remember in Z3 direction we'll have to free it, because it will move in Z3 direction. And now I'll have to assign some velocity, so I'll go to predefined field. I'll simply go to initial mechanical velocity. I'll select this reference point of the rigid body, and I'll assign in -5550. It will be this -5550 meter per mm per second. This will be the velocity that it will be moving. So everything is done. Yes, I have done with everything. I'll simply create a job, and for model 2 create a job. If you have 4 cores in your processor, you can use 4. and if you have 4 cores in your PC, then you can use 4. This will basically increase the speed, and simply submit the job. So that's all for today. Thank you for watching this.